So welcome to the first topic. So this is just an introductory sub topic, and it's a very brief session where we are going to discuss about the basic concepts or the terminology of the ICT. So this is what we are going to cover, a bit of history or the evolution of ICT concepts or the ICT era, the basic concepts and the terminology like data, entity, information, system, and also we are going to look at very briefly what is information system is, and then we will be looking at the communication aspect, which is a very important part of ICT, and finally we will briefly look at some new trends as well. So we all know that the current period of human history is called information age or the information era. So it's a journey. We have passed the hunting era where people develop some tools, basic tools, and also how to work with fire, the invention of wheel. So then we moved on to the agricultural era where the people had more time to discover new things because of the settled lifestyle. And it is that time that the concept or scientific knowledge emerged, and also people start thinking in much more logical manner. People start doing some experimentation, and as a result of scientific knowledge, people start developing some technologies, more and more serious devices, mechanical devices as a starting point, then the electrical and electronic devices. So as part of that evolution, the computing devices were also evolving, and the mechanical computers, the electromechanical computers, the electrical, and later electronic computers. So by 1940s or early 1950s, people were able to develop some serious electronic computing devices. And now we have come to a stage where the information technology has dominated the society. So that is why we call it IT era. It's no longer industrial era, and we are now fully in the information era, and we never know what will happen next, but still the influence of information is critical. So let's move on to the very basics of our subject. So first of all, we need to have some common terminology, and we want to look at few concepts, the basic concepts, in much more serious manner. But we can't talk about information without first look at data. So therefore, let's look at what is data is. So data is attributes or properties of anything. So attributes or properties of anything is called data. Or sometimes we use the word attributes or properties of entities. For example, name of a student, price of an item, the balance of your bank account. So they are all data. And we can see that data is a conceptual or intangible thing. It's not a physical thing. It's not a physical thing like a machine or something. No, it's a concept. Always data is a concept. So let's look at what is an entity is. So I told you that data is an attribute or properties of anything. So the technical term we use for anything in ICT, especially in ICT field, is entity. So therefore, whenever you see the word entity, you can just think of it as anything. Let's look at, or let's try to categorize what are the possible things or what are the possible entities. Right. So these entities can be living physical things or tangible physical living things. For example, it can be a student, customer, employee. So they are all living things and physical things. And of course, the data can be related to these living things. Maybe name of the student, salary of an employee, contact number of a customer. So therefore, we have living things can be entities, and of course, there are data related to those. So the second type of entity, they are non-living physical entities or tangible entities. Something like a machine, vehicle, a product or goods. So they are physical, but there's no life. And of course, we are interested in attributes or properties of those as well. For example, price of an item, name of a product, the registration number of a vehicle. So they are also data. The third one is the most interesting one. There are conceptual entities. I already mentioned you that data is always conceptual, right? Name, price. It's not only data is conceptual. The entities can also be conceptual. So let's look at some conceptual entities or conceptual things. For example, an order. Order is a concept. Payment. Payment is a concept. A bank account. A course. So they are all concepts and they are entities. So why it is the entity? It is something that we are interested. If something we are interested, it's an entity. So therefore, we are interested in the data about those entities as well, attributes and properties of those entities as well. For example, it can be the order date, the amount of the payment, the balance of your bank account, your course name, course fee. So they are all at data as well. So now you can see that the entity can be a living physical entity, non-living physical entity, or it can be even conceptual entity. And all those have attributes and properties that we are interested, and they can be our data. Okay, it's very important that you never ever confuse entities and data, especially when it comes to the third category. Say name, you must know that that is a data. When they say account, you must know that that is an entity. It's not a data. When someone says balance, it is a data, not an entity. Okay, right. So now let's look at the usages of data. Now we know what is entity, what is data. Why are we interested in data? There are few reasons. First, we use data to identify things. For example, name of a person, right? Account number, someone's phone number. So we identify things using data. Secondly, we can use data to account or track things. For example, amount of money transferred. So that amount is a data that we use to track it, account it. The time of arrival of an employee. So we want to account it, track it, so that to check how many number of hours that person has worked. So accounting purposes also we use data. And also we can use data for basic decision making. For example, someone will just look at the time, that is which is a data, and he will decide whether he should continue the work or now it's time to go home. It's a primitive decision. So those decisions you take by looking at those very basic data. Right? If someone gets some, say, marks 48, maybe if the passing mark is 50, it's a very simple decision by looking at the data. So student is failed. Okay, so there are usages of data. Now let's look at the other term, information, because we are more interested about information, right? So what is information? Why are we interested in information? So information is processed data. So when you process data in a particular context, what we get is information. So then someone will ask, why do you want to process it? Obviously, we want to process it to make it more useful. So we are not saying that data is not useful. Data is also useful, right? So the current time, someone's mark. So those are useful to take some decisions as well. But information is usually more useful in a proper context. It's something like the raw rice is useful, but boiled rice is even more useful because it's easier to digest, right? And things like that. So likewise, we use to process data to get information so that we are in a better positions to take some serious decisions, more complicated decisions. So let's take some examples of data and information. For example, unit price of an item, right? It's a data. But if you calculate a bill total, say someone has bought few items, now that person has reached the cashier. Now that cashier is keep scanning. The unit price and the number of items are taken, and you can see that gradually your bill total is prepared. So you are more interested about that billing total. That is your information. Maybe marks of different students. So everyone is ultimately looking at if it is A level or something, the state score. If it is a degree course, the GPA value. So that is the information we need. So therefore data is good, but information is in the proper context, it's always going to be better. So that is why we want to make information systems that is capable of doing that process. So let's see a few of the examples. Some of these are for personal context and some of these can be even in business context as well. Okay. So we can use it for predictions. So they collect those data, the temperature, humidity, the wind directions, the wind speed, all those things, and they analyze it in information systems, of course together with the historical data as well. So they come up with a forecast for next 24 hours. So we all use information system for simple planning when we are using Google Map, right? So it will give you few routes saying that this route will take this amount of time and the distance is that, and there's alternative route. If you take this, it will take say y amount of time. So then you can take your decision. Okay, I will go for this route. Then not only it's giving you the route, then it guide you also, right? So it will guide you how to get into the destination on that route. So that is all about information. Okay, now we are moving to another subtopic because we have discussed about data and information in great length. So now we are looking at the term called system. So first I will explain you why we are interested in systems, because we are really interested in information systems, we are interested in computer systems, we are interested in operating systems, we are interested in database management systems. So therefore, yes, we are interested in systems. So therefore, let's try to look at what is a system means in a little bit more serious manner. So system is set of components, or sometimes we call it set of subsystems that communicate and collaborate to achieve a objective or set of specified objectives. Okay, so set of components communicate and collaborate to achieve a common objective. We call it system. Right? Systems are everywhere. For example, the easiest thing is think about yourself. You are a human. So human is a system. So there are so many subsystems, subcomponents in your body. Right? The respiratory system is there, blood circulation subsystem is there, the digestive system is there, and they all subcomponents or subsystems, and those subsystems also have different components. For example, if it is digestive system, you have the stomach, the liver, and so many other subcomponents of that subsystem also, and they all collaborate and communicate also. And ultimately your body has some objectives. Of course, at least the number one is the survival. So it's try to survive you. Respiratory system, blood circulation systems, providing the nourishment, right? Providing the oxygen, make you active for your day-to-day activities. So that is a system. That is a living system. There are plenty of living systems and non-living systems as well. For example, if you take a power plant, it's a physical system. It's not a living system. If you take a vehicle, so once you provide the power, right, it's a system. It generates the motion, right, the dynamic energy. And again, the interesting thing is we have conceptual systems as well. For example, the most of the systems that we are interested in our subject are conceptual systems as well. For example, information system. It's a conceptual system. Of course, computer system, it has both physical and conceptual things. Operating system, definitely, it's a software. It's a conceptual system. Database management system, conceptual system. It's not only in IT. So we have conceptual systems in the society as well. For example, if you take, say, organization or business organization. So partly it's a concept. Of course, the humans and other physical things are there, but it's a concept. Say legal system of a country, even the government itself, they are all systems, conceptual systems. And here we have so many conceptual systems like operating systems, information systems that we are interested. Okay, so now let's look at what is the information system is. So information system, it's a special system. It's also a system. The only difference is it takes data as input and provide you information. So its purpose of that system is data processing. So then we call it information system. For example, we may be having an accounting system, the exam or examination management system that process results and other things, tax management system, patient management system. So they are all information systems that process data to get the relevant information. So early days, all our information systems were manual information systems. But now we have more and more computer-based information systems. So our manual information systems are now gradually replaced by computer-based information systems. So that is why we are all learning information technology. Because we need people who can do that, who can manage the CBISs, who can develop CBISs. Let's look at the manual information systems first. In manual information systems, we used to store our data in physical media like papers, files, folders, physical folders, etc. and also we used to process it by humans. So the human's brain was used to process those things. For example, say accounting system, a manual accounting system. So we keep our information in books, ledgers, journals, etc. Physical books. And the people do the calculations, debiting, crediting, summing those things to find the balance, carry forward the balance, etc. So that is the nature of manual information system. Or maybe students' information is kept manually. So there are so many disadvantages. Obviously, we need physical space for keeping the files, folders, etc. And it's slow to process because humans, of course, we are intelligent, but we are not very efficient in processing arithmetic or logic, especially in arithmetic operations. We can do it, but it takes time. And also, there's a possibility of errors as well as intentional frauds happening, corruption. So all those are possible in manual information systems. So that is why the people are really interested in converting manual information systems into computer-based information system, because it's very costly. We need a lot of people, and also at the same time it is not efficient. It has possible errors, frauds. So the solution is go for computer-based information systems as much as possible. So in computer-based information systems, we use computers or computer systems. So now the data is stored in electronically, or if it is a permanent storage, sometimes we use magnetism as well. And it's processed electronically as well. It goes through logic gates, or we call them the transistors can act like logic gates, and it gets processed. And obviously the result is need very little storage, the storage of the information system, because the data is stored, or the data or information is stored as a conceptual or the sort of a electromagnetic nature. Then extremely fast processing, like thousands and thousands times faster than the human processing, and less errors, and obviously no corruption, or very little opportunity for corruption if you properly manage the system. Okay, let's look at what are the components of CBIS, or computer-based information system. So we need hardware. It's an information system. Information systems run on computers. So then we need software. So we need the information system itself and supporting softwares like operating systems. So therefore we need software. The database management systems is also software. But because of the importance of database management system or the database, usually we take it as a separate component. Of course, database is again a software, but since we are keeping all the data there, we just take it as a separate component. So then the modern information systems are always relying on networking. So usually the end users will be accessing the information system through the networks or the internet or whatever. And most of the systems also, they are not isolated now. So they also collaborate and communicate with other third-party systems. So therefore, the fourth component of CBIS is network, because network is also a very critical part. So then we need people to enter data, to manage the systems, the security and monitoring, take backups, recovery. So therefore, still we rely on humans for some extent. So therefore we call them the liveware or the people factor. And finally we have the policies and procedures. Especially because the people factor is there, still we need some control of our, especially the people. So therefore we need policies and procedures as well. Right, now we are moving to the final aspect, that is communication. So that is why sometimes we use the word IT and some other times we use the word ICT. So we use the word ICT when we want to little bit more emphasize the importance of communication. Oh, most of the time it's whether IT or ICT, it's the same thing. But when we want to make it little bit more emphasis on the communication aspect, we just use the word ICT. Okay. So let's see what is this communication aspect when it comes to information technology. So communication is exchange of idea or data or information between two or more parties. Right? If you exchange something, conceptual thing like data, we call that it's a communication. It's not a physical thing. If it is a physical thing that we send from one place to the other place, then we say there's a transportation. It's not a communication. Communication is all about exchanging ideas, data, information, etc. So we can identify three types of communication. So what are those? The human to human communication, human to machine communication, and machine to machine communication. So let's look at each and every category. Human to human communication. Of course, that is not our main focus in this subject. So let's look at only the basics of human to human communication, because we will be looking at this more seriously in the other subject. So in human to human communication, we use human languages. And of course, we have two main modes, the verbal communication and the written communication. And of course, there are some fuzziness involving as well, the ambiguity, because human languages are somewhat fuzzy, and also people can make it even more fuzzy as well. So those are some challenges when it comes to human communication. So that is why you have that subject called communication skills, to learn how to do it properly, how to overcome those possible issues. So the second type of communication is human to machine or human machine communication. So that is something we are really interested in our subject, because when we develop systems, we have to come up with user interfaces, so human computer interfaces, so that the end users can communicate with the information system. So we call it either human computer interface or simply just user interface. So the main challenge or the main challenges when it comes to designing and developing HCI or the user interfaces are how to make it user friendly. Because we don't want just a user interface, we want to give the best user interface. So that is one of the interest or one of the study area in IT, how to design effective user interfaces. So then there's another human to machine communication, that is all about programming. So as programmers or as software developers, when we are developing information system, so the program is our communication of the solution to the computer. So there we use the computer languages. For example, it can be programming language like C++ or Java or Python, or it can be another different type of a computer language like a styling language, markup language, HTML, CSS, the query language like SQL, they are all computer languages. And we use those languages to communicate our solution to the computer, which the computer is going to execute it or run it or interpret it. So you can see that this human to machine communication is one of the key part of ICT professionals, especially if someone is in the development or software development field. So the third aspect of communication is machine to machine communication. So again, we can identify two categories, the computer to computer communication, and we call it computer networking, and other electronic devices. So between other electronic devices, they are not fully fledged computers. It may be a CCTV camera, another small electronic gadget in your garage door, okay, the refrigerator, washing machine. So these are also getting more and more into the smart category, and the communication between those are called Internet of Things, IoT, communication and collaboration. So that is also now a new category in machine to machine communication. Again, we have some challenges in machine to machine communication. So we need some common standards so that these devices can communicate. We need addressing schema, possible error handling, reliability. So they are all some concerns or challenges that we have to address in machine to machine or computer to computer or the communication between devices. So let's look at this communication little bit more serious manner. So when it comes to communication, we need at least two parties, or it can be between multiple parties as well, maybe 3 or 4 parties. For simplicity, let's take 2 parties. So then we need a sender, the person or the device that intend to send the message or the idea, and the receiver for that particular communication or messaging. So then your idea or the data will be passed to the other side as a message or set of messages. In order to send that message to the other party, we need a communication channel or communication media. So it can be a wired media like copper wire or fiber optics, or it can even be a wireless media, the radio signals. So when you are doing the communication, we need another very important concept called protocols. So protocol, for example, you may have heard the word like Internet Protocol, IP, Transmission Control Protocol, TCP, Hypertext Transfer Protocol, HTTP. So everywhere you can hear that the word protocol. So what is a protocol? So protocol is an agreed way of communication or standard way of communication. So especially if, now for example, if it is a human to human communication, our protocol is our language. So for this session, the protocol we are using is English language. So similarly, when devices or computers communicate, they need common standard, so that whatever the sender is sending is understood by the receiver. So in that sense, the computer devices use different protocols for different levels. We will be going into details when we are doing the networking subtopic. And again, it's very important to have the feedback or the acknowledgements, because otherwise the sender doesn't know whether the message has reached the receiver or not. And of course, there are a few more things that we want to address when it comes to communication or the networking. The addressing schema, when you have multiple parties, how to set up a connection. In case of errors, how to handle or detect and handle those errors. And also in multi-party communication, we need proper traffic management, routing, and that kind of management aspects as well. So you can see that communication is not that simple when it comes to machine communication. Right, so we are done with the basic concepts and the terminology. Now finally, let's look at what are the new trends in IT. Because it's good time to, when you know the basics, when you know the little bit of history, think about little bit of future as well. So though we call it new trends, some of these trends or most of these trends have been there for some time. So therefore they are not really the brand new trends, but relatively new trends. Okay. And they are going to be extremely important in the future, more than today. So the first one is the artificial intelligence. Of course, artificial intelligence has been there for very long time, but it has been evolving slowly. But now things have picked up, and in the next 10-15 years, the artificial intelligence is going to play one of the key role in ICT. So far, the computers can do processing fast, accurately, but the computer is just a slave. So we programmers write the code, the computer as a slave, obedient slave, just execute it. Intelligence is not that. Intelligence is not an obedient slave. Intelligent is something that you discover things, you adapt to things, you generate new knowledge. So that is what intelligence is. And that is what artificial intelligence is doing. So when it comes to artificial intelligence, these systems are more than executing the commands. So they can adapt to the situations. They can work when there's an incomplete set of data. They can learn. So the second concept is, or the new trend is robotics. So robotics is, now I told you that the data is a conceptual thing. So we are processing data and we are getting a conceptual thing called information. So robotics is, let our information processing devices involve in some physical activities as well. Some mobility, involved in some tasks, physical tasks, help manufacturing, help day-to-day activities. So then we are introducing robotics into the computing devices. And also robotics usually, most of the time, use AI as well, or the artificial intelligence as well. So another concept is cloud computing. So the cloud computing is, rather than saving our contents in our local machines, we save it in the internet. So that is simply the cloud computing. The mobile computing. So we are now using more and more mobile devices rather than the big computers, laptop, desktop. So more and more people are using smartphones to do their day-to-day computing, communication, etc. So that is another trend. Now these days people are using more mobile phones, or they connect to internet and do some serious stuff using mobile phones or smartphones than computers or the desktop and laptop. So therefore we have to think about these users. Then of course the smart technologies. We all know the smartphones, and not only the smartphones, we have other smart devices also, especially in the IoT. Then big data analysis is another area. Right? I already mentioned you about the Internet of Things. So the devices communicating and collaborating with each other, electronic devices, they are becoming smart devices. Another area is augmented reality. So where people work hands in hands with virtual reality. So it's people involved in virtual reality as well. It's a mixture of virtual reality and the physical reality or the reality. Another area is quantum computing. So in quantum computing, we try to do processing in a completely different concept, quantum mechanics. So it's a research area and people have showed some serious progress in certain applications. So of course, quantum computing is not going to replace the normal computing in near future, but quantum computing has its own usage areas like security, especially in encryption, decryption, and think the blockchain technologies, etc. Okay, right. So we start discussing from the very basics terminology, and we identified few terms, few concepts, the very basics, and we ended up with discussing a little bit of the new trends as well. Right. So I hope you got some basic idea, the basic awareness of the basics of ICT, and you are ready to move on to the or dig into more advanced topics in the coming sessions. Thank you.